Fire and smoke detection. Smoke detection systems monitor certain areas of the aircraft for the presence of smoke, as this is indicative of a fire condition. Areas monitored may include cargo and baggage compartments and lavatories. Fire detection systems should signal the presence of a fire. Units are located in areas where there is the greatest possibility of a fire. Overheat warning systems are also used to indicate areas of high temperature that may lead to a fire. Fire warnings are indicated to the crew, both visually and orally. Cargo compartments. Class A. The presence of fire is easily detected and each part of the compartment is easily accessible in flight. Class B. There is sufficient access in flight for crew to effectively reach any part of the compartment with the contents of a hand fire extinguisher. Separate smoke detector fire detector systems give cockpit warning. Class C. Does not meet Class A or B fire requirements, but there is a smoke detector fire detector system and a built-in fire extinguishing system. Class D. The fire will be completely confined without endangering aircraft safety. Ventilation can be controlled. Class E is found in aircraft used only for carriage of cargo. Separate smoke fire detector systems are present and ventilation can be controlled. In transport aeroplanes, overheat detection devices are installed in the landing gear bays and wheel wells. Class C, lower cargo compartment, example. Class E, main deck cargo compartment, example. Carbon monoxide and smoke fire detectors. Carbon monoxide detector, a yellow silica gel which turns various shades of green in the presence of carbon monoxide. Smoke fire detectors come in 3 different types: those working on light refraction, ionization, and solid state, which operates on the principle of changes in resistance of a semiconductor material. As resistance decreases, current increases, and an alarm is triggered. Smoke detectors can give false warnings due to dust, dirt, and condensation. Cosmic radiation can lead to ionization. Smoke detectors. A beacon lamp passes light through the detector. If there are any smoke particles present, they are refracted and picked up by a photoelectric cell. Ionization. Flight level 350, cosmic radiation may trigger false alarms. Radioactive material used to ionize oxygen and nitrogen molecules in the air drawn into the detector. The ions permit a small current flow in the detector. Any smoke particles in the air attach themselves to the oxygen and nitrogen ions, thereby reducing the current flow. Engine fire detection systems may be spot detection type or continuous loop type. Spot detector. The individual fire detector or switches give a fire warning only if a fire exists in the same location as the detector. Continuous loop. This works on the same principle as the spot detector, but the switch is in the form of a long tube rather than individual switches, which runs around the engine compartment, for example. Systems in common use are a thermal switch, thermocouple, continuous loop, and pressure sensor. Thermal switch. Bimetallic strips of metal close when the temperature reaches a predetermined value and is used for spot detection. When bimetallic strips are used, a fire alarm is triggered after a delay. The purpose of this is to avoid false alarms in the case of vibration. Thermocouple. This operates on the principle of rate of temperature rise rather than at a predetermined temperature used in spot detection. Active thermocouples are placed in locations where fires are likely to occur. A reference thermocouple is placed between 2 insulated blocks. Under normal conditions, temperature around the active and reference thermocouples rise at a gradual and uniform rate. If there is a fire, however, the active thermocouples heat up at a much faster rate than the reference thermocouple, therefore initiating a fire warning. Continuous loop. A type of fire detection system which uses 2 conductors separated by a thermistor material formed into a continuous loop that surrounds the area being protected. A thermistor is an electrical insulator at normal temperature, but becomes a conductor when heated. When a fire occurs, the thermistor conducts electricity and completes the fire warning circuit. This turns on the fire warning light and starts the fire warning horn or bell. Continuous loop operates on the principle of a reduction in resistance as temperature increases, i.e. a negative coefficient of resistance or a positive coefficient of capacitance. Continuous loop systems automatically reset following a fire overheat warning, provided the condition has been rectified. In a loop system with no fault protection, if the line is accidentally grounded, the fire alarm is triggered. Pressure sensor. These systems contain an element in a sealed tube which absorbs gas at low temperatures and releases it as the temperature increases. As temperature increases, more gas is released and the pressure in the tube increases. At a predetermined pressure and therefore temperature, an alarm is set off. A gaseous sensor responder tube fire sensor is tested by heating up the sensor with test power connection. The fire extinguishing system for a nacelle must be able to simultaneously protect each zone of the nacelle for which protection is provided. The indication of the fire detection system is performed by a warning light for each engine and a single warning bell common to all engines. With engine fire alarm activated, the extinguisher discharge is the pilot's task. When a wire-type fire system is tested, the wiring and the warning are tested. This is a typical layout for engine fire protection. The 1 and the 2 represent the fire handles. There's a fire bottle for each engine, which can be extinguished into engine 1 or engine 2. Fire bottle 1 is used for engine 1 normally. Fire bottle 2 is used for engine 2 normally, but there is a second shot possibility by transferring one side to the other. If, for example, a fire were detected on engine number 2, then the fire shutoff handle number 2 should be pulled and turned, thus discharging bottle number 1 into engine number 2. In a multi-engined aircraft, a fire detection system includes a warning light for each engine and a single alarm bell common to all engines.